Hello everyone, my name is Rohan Padaya, and today I will be talking about a project that involves customer segmentation using clustering algorithms. The goal of this project is to create clusters of customers of a bank based on their transactions and credit usage patterns. By identifying these clusters, the idea is to help the bank tailor its marketing strategies more effectively for each customer group. In this video, I will take you through each step of the analysis and the decisions made along the way. All right. So to begin with, we load our data set, which is inside a CSV file. We print the first 5 rows of the data to check whether the load is done correctly. Then we print the information of the data, like we print the types of columns that we have and the data types of each column. We then describe the range of values in our each column. So the describe method basically gives us the mean value, the minimum value, the maximum value of each column. And as you can clearly see, there is some of our columns are on different range or a different scale. So moving ahead, we need to bring them on a similar scale so that we can perform clustering analysis on them. Then we check the number of null values in each of our columns. And as you can clearly see, there are two columns with null values, credit limit and minimum payments. We replace these null values with a median value of that particular column. You can replace it with mean as well, but for our analysis, we have chosen median. Um, then we move on to exploratory data analysis, EDA. So to begin with, we first plot the histograms of our key numeric variables just to check their distribution. So as you can see, most of our histograms are right skewed in nature with a long tail on the left, which suggests that there are outliers. There are two segments of customers basically in our data. Even before doing any sort of clustering analysis, we can clearly see that there are two segments of customers. Then we use box plot to check whether we have any outliers in our data. And as you can clearly see, most of our columns have outliers. We use correlation heat map to identify strong correlations between our columns. And as you can see, there are some columns with strong correlations and there are some columns with negative correlations. We use standard scalar to scale our data before applying any clustering. We need to first bring our data on a similar range, and standard scalar basically helps us to do that. Now, after completing our pre-processing, we then perform clustering analysis. As part of our analysis, we are using two algorithms, k-mean algorithms and dbScan algorithms. So to begin with, before we do, before we apply k-means algorithm, we need to identify the optimal number of clusters for our k-means algorithm. And for that, we use elbow plot. So elbow plot basically tells us which is that particular value of n, which gives us the optimal number of clusters. So as you can see, there's a clear elbow forming around n equal to 4, which means that n equal to 4 is our optimal value for k-means clustering. So we use that optimal value to perform k-means clustering on our data set. And this is the plot that we get. And as you can clearly see, there's a lot of overlap between our four clusters, which suggests that our k-means clustering is not performing well on our data set. And we use a statistical metric called silhouette, which basically suggests the effectiveness of our clusters. If this value is closer to 1, then the clusters are distinct and effective. If it is closer to 0, that means the clusters are not effective. And clearly, we are getting a value closer to 0. That means our clusters are not effective, and even the plot suggests the same. To improve our k-means algorithm, we have performed principal component analysis. PCA basically helps us to reduce the dimensionality of our data. So since we have 17 components, we have 17 features in our data set, correct? So we need to identify the features or the components which strongly uh, vary our data, which strongly relates to our analysis or strongly gives us the clusters, right? So using PCA, we identify components which strongly uh, which explains the maximum variance in our data, to be precise. And as you can see, using cumulative explained variance, we can see that 90% of our variation in the data is explained by 10 components. So we don't need all the 17 components. We just need 10 components because we want to reduce the dimensionality of our data. Correct? So using PCA, then we perform k-means clustering on the 10 components that we have found. And we can clearly see there is improvement in our clusters. So the overlap is reduced, and now you can distinctly see the clusters. but the silhouette score is still lower, which suggests that even though we can visibly see four distinct clusters, there's still a lot of overlap. So now, as part of our analysis, we then move on to DB-scan algorithm and see if we can find a better silhouette score for this particular algorithm. So we perform DB-scan algorithm, and we find two distinct clusters for DB-scan algorithm. But again, the silhouette score is closer to zero, suggesting that there is a lot of overlap. So to improve this further, we tune the DB-scan algorithm by changing the values of EPS and minimum samples. And now we are getting distinct clusters. And the silhouette score has also significantly improved. So using the tuned DB-scan algorithm, we are able to find two distinct clusters, wherein one cluster are the customers with high risk, and one clusters are customers with low risk. So high risk ones are typically the outliers, and the low risk ones are the low ranging customers. And by low risk meaning, as you can see, using our tuned DB scan, we have found the average values of each of the columns. And as you can see in cluster one, the average value is 4,000, whereas in cluster zero, the average value is quite low, which is 1,400. So clearly suggesting that there are customers who have higher balance and customers with lower balance. So using this, we are then plotting the average values for each columns for each cluster. And as you can see, the one cluster customers have higher balances, whereas the other cluster customers have lower balances. And similarly for all the other columns, it's the same. So interpretation of the cluster profiles. Uh, so the key insights for cluster one represents higher risk customers, as I said, with large balances, frequent cash advances, high credit limits, and high minimum payments. Cluster zero represents lower risk customers with lower balances, lower spending, and low credit limits. So what are the potential strategies that a bank can deduce from this? So for cluster one, the bank can provide debt assistance because they basically are high risk customers, so debt assistance will definitely help them. They can provide lower interest rates, and they can also provide credit line increase on spending milestones. So if let's say a customer spends a particular limit, let's say they spend $1,000 within the next 3 months, so then the bank can provide them additional 500 credit line increase so that they can further use the credit card even more, and which will eventually help the bank. For cluster zero, they can they can provide rewarding programs. They can provide safe credit offers and provide exclusive perks so that these customers can take more risk and spend more on their credit card. So these are some of the recommendations based on the analysis. Thank you so much.